every type of galaxy collision. Space is complicated. We make it simple. Galaxies don't just sit in space, quietly orbiting alone forever. They fall into each other over hundreds of millions of years, pulled in by gravity across distances so vast that the collision itself happens in slow motion, almost too slow for a human lifetime to register as motion at all. And here's the part that should unsettle you before we even start. Our own galaxy has already done this before, is doing it again right now in a small way, and is on a collision course to do it again on a massive scale. We're going in order from the smallest, gentlest galactic interactions to the most violent, most transformative ones. Then we'll sort them a second way by what actually survives the encounter. Because on this list, collision almost never means destruction, the way you'd expect. Galactic Flybys. We begin with the gentlest version of this category and also the easiest to misunderstand because nothing here technically merges into anything else. A galactic flyby happens when two galaxies pass close enough for their mutual gravity to visibly distort each other's shape, stretching out long, thin streams of stars and gas called tidal tails, without the two galaxies actually colliding or merging into a single object at all. Here's the fact that should genuinely bother you. Even a flyby with no direct collision can permanently reshape a galaxy structure, triggering new bursts of star formation as gas clouds get compressed and disturbed by the passing gravitational tug, and in some documented cases, warping a previously flat, orderly spiral galaxy's disk into a visibly bent, asymmetric shape that persists for hundreds of millions of years afterward. Here's the part that lingers. Two galaxies can complete an entire flyby, swing past each other, and drift back apart into what looks from a distance like two ordinary separate galaxies again, except both of them now carry a permanent visible scar from an encounter that, on a human timescale, would have taken longer than the entire history of civilization to fully play out. Minor mergers. Here's the twist. Not every merger is a clash between equals. When a large galaxy encounters a much smaller companion, often a dwarf galaxy a fraction of its mass, the smaller galaxy typically doesn't survive the encounter as an independent structure at all. It gets gravitationally shredded, its stars and gas gradually stripped away and absorbed into the larger galaxy's own structure, sometimes over the course of several close orbital passes rather than a single dramatic impact. Here's the fact that should genuinely bother you. The Milky Way is doing this right now and has been for a very long time. The Sagittarius Dwarf galaxy, a small companion galaxy, has been slowly torn apart by repeated passes through the Milky Way's disk over the past several billion years, and its shredded remains form a long, faint stream of stars that wraps around our entire galaxy multiple times, meaning some of the stars visible in Earth's night sky right now didn't originally form as part of the Milky Way at all. They belonged to a smaller galaxy we've been slowly, quietly consuming for longer than the solar system has existed in its current form. Major mergers between comparable galaxies. Here's the reframe. This is the category most people picture when they hear galaxy collision, and it's dramatically more violent and dramatically slower than any collision on Earth could prepare your intuition for. When two galaxies of roughly similar mass collide, the individual stars inside them almost never physically hit each other at all. The distances between stars within a galaxy are so vast that a direct stellar collision is statistically almost impossible, even during a full galactic merger. Here's the fact that should genuinely bother you. What does collide catastrophically is gas and dust compressed and shocked by the encounter into some of the most intense bursts of new star formation observed anywhere in the universe. It's sometimes producing hundreds of times the normal rate of star birth in a relatively short cosmic window, a phenomenon astronomers call a starburst galaxy. The Antennae Galaxies, two mid-sized spiral galaxies currently in the middle of exactly this kind of collision, roughly 60 million light years from Earth, display exactly this signature, long curving tidal tails of displaced stars and gas, and bright clusters of newly formed stars glowing in regions where the two galaxies' gas clouds have slammed together. Here's the part that lingers. A major merger like this one takes several hundred million to over a billion years to fully complete, meaning every photograph we've ever taken of a merging galaxy pair is a single frozen frame from a process so slow that no human civilization, however long it survives, will ever witness its beginning and its ending within the same lifetime. The eventual fate of the two central supermassive black holes. Here's the pivot. Every large galaxy has a supermassive black hole anchoring its core, and when two such galaxies fully merge, those two black holes don't just politely coexist. They're gravitationally drawn toward each other over the following hundreds of millions of years, eventually forming a tightly bound binary pair orbiting each other at the new combined galaxy's center. Here's the fact that should genuinely unsettle you. Getting from a wide binary orbit down to an actual merger isn't guaranteed to happen quickly or at all on any predictable timescale. Theorists have identified what's sometimes called the final parsec problem, a genuine gap in our understanding of exactly what mechanism allows two supermassive black holes to lose enough orbital energy to finally spiral all the way in and merge, rather than getting stuck orbiting each other indefinitely once they get close. When a merger does complete, the resulting collision releases a burst of gravitational waves so powerful that astronomers now use dedicated pulsar timing arrays specifically to search for the faint, slow ripple these supermassive mergers should be constantly producing throughout the universe. Here's the part that lingers. A merging black hole binary can, under certain conditions, release its final gravitational wave burst asymmetrically, giving the newly combined black hole a powerful recoil kick that can fling it entirely out of the center of the newly merged galaxy. Meaning, some galaxies observed today may be missing their central black hole altogether, quietly ejected sometime after their last major merger. Cannibal galaxies and repeated feeding. Here's the fact that reframes the entire scale of this category. Some galaxies aren't defined by a single dramatic collision at all, but by an ongoing pattern of repeatedly consuming smaller neighbors over billions of years, growing steadily larger with each successive meal, rather than through one transformative event. Elliptical galaxies, generally the largest and most massive galaxies observed in the universe, are believed to form largely through exactly this process. Repeated mergers, both major and minor, gradually erasing the elegant spiral structure of the original galaxies involved and replacing it with the smoother, more featureless, egg-like shape typical of a giant elliptical. Here's the fact that should genuinely bother you. Astronomers can actually read a galaxy's cannibalistic history directly in its structure by identifying faint shells, ripples, and streams of stars in its outer regions, essentially fossilized evidence of specific past meals, each disturbance corresponding to a smaller galaxy that was absorbed and disrupted at a different point in the larger galaxy's history, preserved for billions of years because stellar orbits at a galaxy's outskirts take an extraordinarily long time to fully smooth out and settle. Here's the part that lingers. The largest galaxies at the centers of massive galaxy clusters, sometimes called brightest cluster galaxies, appear to have grown almost entirely through this repeated cannibalism, some containing the faint stellar remains of dozens of smaller galaxies absorbed over cosmic time, essentially graveyards built from a long history of consumed neighbors. The Milky Way and Andromeda's past collisions. Here's the fact that brings this list back home in the most unsettling way possible. Our own galaxy isn't a pristine, untouched original. Evidence embedded in the motion and chemical composition of stars throughout the Milky Way strongly suggests our galaxy underwent a major collision with another substantial galaxy, sometimes called the Gaia-Enceladus merger, roughly 8 to 10 billion years ago. An ancient collision so old and so thoroughly absorbed that its evidence exists today only as a distinct population of stars moving on unusual telltale orbits, rather than as any visible structure you could point a telescope at directly. Here's the fact that should genuinely bother you. Andromeda, the Milky Way's large neighboring galaxy, shows even more dramatic evidence of a violent past, including a disturbed outer disk and multiple satellite galaxy streams, consistent with a significant merger of its own within the last few billion years. Here's the part that lingers. Neither galaxy we casually think of as ours and the neighbor is actually the original untouched structure that formed billions of years ago. Both are already the surviving reshaped product of at least one previous major collision each, long before either of them ever had the chance to notice the other existed. The Milky Way-Andromeda collision still to come. Here's the fact that closes this list on the one collision that will eventually genuinely happen to us. The Milky Way and the Andromeda Galaxy are currently approaching each other at roughly 110 kilometers per second, and current trajectory calculations put a first close pass at around 4 to 4.5 billion years from now, with a full merger completing several billion years after that, eventually producing a single larger elliptical galaxy that astronomers have informally nicknamed Milkomeda. Here's the fact that should genuinely bother you and also somehow comfort you. Despite both galaxies containing hundreds of billions of stars each, the actual probability of any two individual stars physically colliding during the entire encounter remains astonishingly close to zero. For the exact same reason, true stellar collisions are vanishingly rare in every merger on this list. The empty space between stars, even within a densely packed galaxy, is simply too vast for a direct hit to be statistically likely, even across a merger involving that many stars over that many billions of years. Here's the part that lingers. By the time this collision fully plays out, the sun will already be in the final swollen stages of its own life, meaning whatever remains of the solar system that far in the future will experience this entire galactic merger as background scenery to a much more immediate and far more personally relevant ending of its own. Galaxy harassment in dense clusters. Here's the fact that closes out the list with the slowest, least dramatic looking form of collision on it, and also one of the most destructive over long enough timescales. Inside a dense galaxy cluster containing hundreds or even thousands of galaxies packed relatively close together, an individual galaxy doesn't need a single dramatic collision to be reshaped at all. It can be gradually worn down by repeated cumulative gravitational tugs from many different neighboring galaxies over billions of years, a slow grinding process astronomers sometimes call galaxy harassment. Here's the fact that should genuinely bother you. This repeated low-level gravitational disturbance is believed to be a major reason why galaxy clusters contain a disproportionate number of featureless, gas-depleted elliptical and lenticular galaxies compared to the gas-rich, actively star-forming spiral galaxies found more commonly out in sparser regions of the universe. Cluster galaxies don't need to be consumed to be transformed. They just need to spend long enough in a crowded neighborhood, taking a slow, continuous beating from everything nearby. Here's the part that lingers. Unlike every other collision on this list, which involves one clearly identifiable event or pair of galaxies, harassment has no single culprit and no single moment of impact at all. It's death by 1,000 gravitational cuts, inflicted by an entire crowded neighborhood acting together over cosmic time. Let's sort these 8 again, a different way, not by violence, but by what actually survives the encounter. On the fully intact end, galactic flybys, where both galaxies drift apart afterward, permanently reshaped, but never actually merged into one. On the one-sided survival end, minor mergers, where the smaller galaxy is completely absorbed and effectively ceases to exist as an independent structure, like the Sagittarius dwarf currently being consumed by the Milky Way. On the mutually transformed end, major mergers between comparable galaxies where neither original galaxy survives in recognizable form, both dissolving together into an entirely new combined structure. On the eventually inevitable end, the central supermassive black holes, which may take so long to actually merge that the surrounding galaxies have already fully combined around them decades, or eons, before the black holes themselves finish the job. And on the still to come end, the Milky Way and Andromeda, a collision so far in the future that not one currently living thing anywhere in either galaxy will exist to see even its opening stages. It's worth understanding before we close exactly how astronomers can even claim to know any of this happened, given that no human civilization has existed long enough to watch a single merger unfold from start to finish. The answer is essentially cosmic snapshotting. Because light takes time to travel, looking at galaxies at different distances from Earth means looking at different points in cosmic history simultaneously, and astronomers have identified enough merging galaxy pairs at enough different distances, and therefore enough different stages of collision, to assemble a complete timeline purely by comparing many separate frozen single frames from many separate collisions happening at different distances. Here's the fact that should genuinely bother you. This means nobody has ever directly observed one single merger progress from first approach to final combination. The entire multi-hundred million year story has been reconstructed the same way you might figure out how a flower blooms by photographing 1,000 different flowers, each at a different undisclosed stage of opening, and then arranging the photos in the correct order afterward. Here's the last thing worth sitting with. Every large galaxy in the observable universe, including the one you're currently living inside, got to its current size and shape, at least partly by consuming something smaller, or by colliding with something comparable, over a timescale so vast that not a single generation of any species could ever witness the whole process unfold. You are right now living inside the reshaped aftermath of a collision that happened before the sun existed, on your way toward a second one that won't finish for billions of years after you're gone. Not bad for stick figures on a rock.